Good morning, everyone. Shall we begin the session? Today's topic is the same, that is software. We have finished with the hardware in the last class. What are the various hardware components? Yes, we have finished with the software, but not exactly we can say, but yes, application software is pending out. Okay, so just read it, whatever we have studied in the last class. Just go through with this. So let's start with a session of the software. So whatever the software, so this is a program that controls the operation of the computer system. And software is divided into two parts. One is application software, one is system software. And system software is again divided into two parts. One is operating system, one is a language processor. In the same way, application software is divided into two parts. One is a utility program, one is a basic software on the integrated or the special purpose software. This we have done yesterday. Now, this is also we have done yesterday in this. Now, this is the main topic, that is the software that is divided into two parts: system and the application, operating system and the programming languages, general purpose and the special purpose. And this includes the software that is responsible for passing information to and from the system or the user, communicate with and controls the system. So operating system communicate with and also controls the system by the operating system only, and the pictures GUI, that the picture graphic icons to represent the commands. Then Windows, a way of looking on several applications at once. That means it is a way of handling multiple applications at the same time. Then next one is a menu driven, that is there is a menu bar, there is a pull down menu for the choices. Then command driven, there is a system prompt, the user types in single letter words line which is translated into an instruction for the computer. For example, if I'm talking about the CP that is used to copy the source for the destination, that needs to be very familiar with the syntax grammar of the command language. Then it is a software that manages the overall operation of the computer system, and the main purpose is to support application program. It hides the details of devices from the application program. So its main purpose, or the operating system main purpose, is to hide the details of the devices from the application programs. The operating system is again divided into four parts. One is a shell, the network interface that coordinates the multiple tasks in a single computer. Then there's a task scheduler, coordination of the multiple tasks into a single computer. Then kernel, that software which ties the hardware to the software. That means whenever the hardware wants to communicate with the software, that is provided by the kernel. Next, kernel also manages the software, that is the flow of the information, how it is passed, what are the various printer, what are the various keyboard devices that is used with the input output, that is done by the kernel only. The next one is a file handling, that is a collection of information. So when we collect multiple data record, that is known as a file. So when we collect the data and store on the disk, that is known as a file handling. Then a disk needs to be formatted to allow them to store the information. And operating system also manages the location of files on the disk, and it also performs the input output to the disk and checks and corrects the error on the disk input output. Then device drivers, so there is a program which handles the various hardware devices, example mouse, keyboard, CD, video, and so on. For example, an application wants to print a document, then it calls the operating system, which sends the information to the device driver together with the instructions, and the printer driver that handles all the control of the printer, whatever the control, whatever the devices, whatever the tool that is using this is used to print a command, that is Yes, it acts as a mediator between the printer and the application software. Then it is of two types, single tasking and the multitasking. Single tasking, that runs only one application at same time. Multitasking, more than one application can be active or can run at the same time. For example, if I'm talking about the DOS, disk operating system, that is a single tasking command driven, huge number of applications written for the DOS, and that does not require the powerful computer, no network services, no multimedia expansion, so the extension then designed for the Intel 80 and yes 18 to 86 processors. Then next one is the Windows that we are using. For example, if I'm talking about the Windows 7, Windows 8, Windows 10, all are the Windows. This is of the GUI environment, can also run the DOS programs, has a network services. There are the multiple network connections that we can use. Multimedia extensions are also available. Also requires a large amount of memory, disk space, powerful processors. Then it is also designed for the various processors. The next one is a Macintosh operating system. This is again the multitasking, GUI non-finder, very easy to use, very graphically oriented, has a network services, multimedia extensions, designed for the Motorola and the PowerPC extensions or the processors. The next one is a special purpose of application software. Yes, one is payroll. For example, if I'm talking about the payroll, your organization have a different payroll criteria. Our organization have a different payroll criteria. So it depends on the purpose to purpose. It depends on the organization to organization. What is the payroll criteria? So that is a special purpose. One is a payroll. Then accounting. That is also the same with the payroll, with the bookkeeping. The entertainment is also special purpose in the yes. Right. The general purpose is that is common to each everyone. For example, if I'm talking about the Word, that is common to each and everyone. Excel, PowerPoint, Access, Mail. So these are the general purpose application software that is common to each and everyone. Next one is the integrated software, and the goal is to make the effective sharing of the information between all the applications. For example, if I'm talking about the Office, Excel, PowerPoint, Access can also use each other data directly. Then OLE, that is integrated software, object linking and embedding, and it is stored in one location only. That is referred is made from another application. Now this is the OLE, object linking and embedding, that is used to make the linking embedding that is also possible with the help of the application software only. Now next is the operation of the processor and the memory. How the processor works, how the operation of the processor performs, and how the memory performs. So processor is a functional unit that interprets and carries out the instructions. So whatever the instructions, whatever the data, whatever the functional unit that interprets and carries out the instruction with the help of the processor, it is also known as a CPU. That is central processing unit. And every processor has a unique set of operations. That may be any operation, that may be arithmetic, that may be logical, any operation that is used. And then load, add, and store. So first of all, load means storing in the memory, then perform the calculation, that is again it is storing in the store. The next one is a processor. So whatever the this set of operation is known as the instruction set, also referred as the machine instructions, and the binary language in which they are written is known as the machine language or the machine instruction. An instruction also comprises an operator that specifies a function operand on which the operation is performed or the data on the to be operated on. So one is operator. For example, if I'm talking about the plus minus, that is operator. If I'm talking about the ABC, that is operands. For example, if I'm talking about the add operator, that also requires the two operands that must know what the two numbers are and where the two numbers are. Add is used to what the two numbers are, that is A and B, and where they are stored, that also requires the two operands. And if the data, that is a number to be added, is in memory, Then the operand is also known as the address. So one is ADD, num1, num2. The num1 could be a number or it could be the address of a number in the memory. That is where the number is stored. Then these are the various categories of the machine language instruction. One is the arithmetic, that is addition, subtraction, division, multiplication. Then logical, and or not, exclusive or. Then program control, branching, subroutine. Data movement, move, load, and store. Then input, output, read or write. So these are the input output operations. One is a read, one is a write. One is a data movement, move, load, and store. Then program control, branching and the subroutine. Then logical, and or not, exclusive or. Then arithmetic, addition, subtraction, multiplication, and the division. And the processor's job is to retrieve the instructions from the memory, retrieve the data from the memory, perform the operation, maybe stores a result in the memory, retrieve the next instruction. So this step-by-step operation is repeated over and over at speed measured in the millions of the seconds, and the clock also governs the speed, and each step must wait until the clock ticks to begin. So whenever the clock ticks to begin, so this we use with the clock signal. And there's a 300 megahertz processor that will use a clock which takes about 300,000 seconds or times a seconds. Then these are the components of a processor. One is the input, memory, output, CPU, there's the control unit, arithmetic and the logical unit, and the registers. Then what is a control unit? This supervises the operation of the processor, makes a connection between the various components. The CU supervises the operation of the processor, makes the connection between the various components, invokes the operation of each component, supervises the operation of each component, and it can be interrupted with the help with the CU. Then interrupt, what is an interrupt? That is a signal that tells a control unit to suspend the execution of its present sequence of the instruction. It also transfers to another sequence, resuming the original sequence when finished with the B. Then this is the interrupt. There is a A1, A2, A3, A4, A5. Again, they are the instructions B1 till Bn. Then execute statement is used to execute each and every instructions. And the branch is to set or use or branch to new set of operations, whatever the new operation that we are dealing with. Then a CU also receives the instructions from the memory, decodes them, that means converted into the next language. Then breaks each instruction into the sequence of the individual actions. So in this way, it controls the operation of the computer. Next, the ALU, that is used for the arithmetic and that is stands for arithmetic and logical unit, that provided the computer with its computation capabilities, and the data are brought to the ALU by the control unit, and ALU also performs the required operation, whatever the required operation that is performing out. Arithmetic operations includes addition, subtraction, multiplication, division, and the logical operations includes CMP, AB. Then registers, that is the storage purpose, storage location inside the processor. Control unit register, that is stores the next instruction, location of the next instruction to be executed, then the operands of the instruction. Then ALU registers, that stores the data item, stores the results. Then registers is word size, word length, and the size of the operand register. Also used to describe the size of the pathways to and from the processor and between the component of the processor. Whatever the component we are using, whatever the word size we are using with the registers. That is of the 16 to 64 bits. If it is of 16 bit, this is 2 power 4, and if it is 64 bits, this is 2 power 6. Yes, 2 power 4 is 16 and the 2 power 6 is 64. The next is 32-bit processor. Then the operand registers of a processor are 32-bit wide, that is a low. The next is specialized processors. One is DSP, digital signal processor. One is math coprocessor. One is application specific integrated circuit. For example, one of the best example is the microwave. Yes, microwave controller. Then operation of the processor, how it is operated out. One is used by the accumulator based CPU, that is a von Neumann computer. Then ALU, all the computation, all the calculations are performed in this unit. ALU comprises the adders, counters, and the registers. And the numerical operations includes plus, minus, divide, and multiply. And logical operations and or branching or the program branching. Then registers capable of receiving data, holding it, and transferring it as directed by the control unit. Then adder, this receives data from two or more sources. Then counter counts a number of times an operation is performed. Then instructions are again coded as a sequence of the binary digit. Data are coded as a sequence of binary digits. Registers are simply physical devices which allows these codes to be stored. Then memory is just the same. How does a computer evaluate a simple assignment statement? This is A equals to B plus C. A computer can't evaluate this directly because it is not written in a way which matches the structure of the computer. Firstly, this must be translated in a sequence of the instructions which does match the computer architecture. This is CPU, this is AR, then DR, PC, IR, control circuit, PCU, AC, ALU, arithmetic, logical circuit. This is address register, accumulator, program counter, instruction register, ALU, arithmetic and the logical unit, PCU, program control unit. This is the format that is divided into two fields. One is the opcode, one is the address. Just read it. Shall we start? Okay. So this instruction format is divided into two fields. One is the opcode, one is the address, and that is used. Yeah, this may vary in the size. First is load X. This puts the contents of memory location X into the accumulator. Then add T. This adds the content of the memory at location T to the content of the accumulator. Then store Y. This puts the content of the accumulator into the memory at location Y. Whatever the memory location, whatever the accumulator that is using up, that is used with the instruction format, that is used with the IR, instruction register also. This is another example, that is how to evaluate an assignment. One is A equals to B plus C. So first of all, we have to load the B, then add the C, then store the A. Why? Because when we load the B, it is A is, or the C is added up into the C, and then it stores the A. And this is the load B input. This is 1111 0100 1100. This is 6 times 0 and 1. Then output. Then AR DR. But the instructions are stored in the memory also. This is used like this one. So the load B, first of all, it is loaded in the B, then add the C over here, then stores the B. So it works more like this. This is A equals to B plus C. The next one is the instruction cycle, that is used with the fetch cycle, that fetches the instruction from the memory, executes the cycle, that is means decodes the instruction, fetch the required operations, and perform the calculations. An instruction cycle comprises a sequence of the micro operations, each of which involves a transfer of data to and from the register, that is used with executing the instruction with the CPU, supervises other system component, usually via special control lines. And it also controls the input-output operations, input-output systems. And it is a relatively infrequent event. It usually ignored until they actually request a service from the CPU via interrupt. This is the interrupt. Just starts, instruction awaiting execution, fetches the next instruction, execute next instruction, that is execution cycle. Then register transfer language restores the location in CPU and memory and refers to as the acknowledge. This is the accumulator, main operand register of the ALU. Then DR, data register, this is the buffer, or it acts as a buffer between the CPU and the main memory. It is used as an input operand register with accumulator to facilitate the operation of the form AC. This is for the F, AC, DR. Then PC, program counter, this stores the instruction of the enters of the next instruction to be executed. Then IR, this holds the opcode of the current instruction. Current instruction means whatever the instruction that is fetching out. Then AR, address register, holds the memory address of an operand. Then this transfers the content of the storage location B to A, whatever the B location, whatever the content that is using up. Then A, memory of DR, whatever the memory that is using up,